In this section, we'll turn broad ideas into implementable AI, blockchain prototypes. You'll learn how to run a focused literature review, extract real research gaps, design robust system architectures, and plan realistic prototypes suitable for a PhD-level Saudi context. Across this course, every project blueprint follows the same reusable end-to-end methodology. You begin with a systematic literature review that anchors your idea in existing evidence and reveals real research gaps. You then translate those gaps into a concrete multi-layer architecture that respects domain constraints in Saudi contexts. Finally, you plan prototypes and evaluation, technology stack, datasets, metrics, and experiments that can support a defensible PhD thesis. Anchoring a research problem means drawing a clear box around what you will and will not do. Start by setting a tight scope, so success is measurable. Specify the domain in a Saudi context, for example, Jazan Agritech, rather than agriculture in general. Clarify whether your main goal is prediction, optimization, or security. Then list the key constraints and turn all of this into precise research questions and hypotheses. A systematic literature review is your engine for uncovering real gaps, not just collecting citations. You begin by planning. Define the exact question, scope, and protocol, so another researcher could repeat it. Next, search multiple databases with transparent queries. Then screen the results using explicit inclusion and exclusion rules. Finally, analyze the selected papers, extracting patterns, inconsistencies, and open problems that justify your PhD project. For these projects, your literature search should deliberately sit at the intersection of three things: the domain, AI or machine learning techniques, and blockchain or distributed ledgers. Use combined keywords to force that overlap and avoid being flooded with generic AI or generic blockchain papers. Narrow further by prioritizing high-quality databases and keep only work with real data, implemented architectures, or evaluations that you can build on or challenge. A concept matrix helps you see patterns across existing studies instead of reading them one by one. Along one dimension, list AI methods, blockchain platforms, and data types. Along the other, list domains or use cases. Then mark what each paper actually uses. The real value lies in the empty cells, combinations no one has explored yet. Those become concrete, justifiable candidates for your PhD research direction. Next, you move from an interesting idea to an architecture you can actually build and defend. Start with a conceptual model, actors, data flows, and trust boundaries. Then refine it into a technical architecture, assigning each responsibility to a layer. Make sure every design choice traces back to a specific research question. Think of this layered architecture as your default template for almost any project in this course. At the bottom, you manage raw data and enforce privacy. Above that, AI services turn data into predictions and decisions. The blockchain layer records critical events and agreements with integrity guarantees. At the top, interfaces expose everything to users and other systems. By separating concerns, you can swap technologies, scale parts independently, and reason clearly about security and compliance. AI and blockchain only become powerful together when you design the bridge between them. Imagine AI models and real-world data running off-chain, then publishing their results in a verifiable way on-chain. Oracles act as secure couriers that fetch, validate, and sign that data. A pattern you'll reuse in many PhD projects is off-chain AI inference, on-chain verification, with APIs and SDKs handling the integration. Prototype planning is about choosing a coherent technology stack, not chasing every shiny tool. Begin from your research constraints. If you need heavy deep learning, prioritize Python with PyTorch or TensorFlow. For lighter models, scikit-learn may be enough. For blockchain, public experimentation often suggests Ethereum or Polygon, while strict privacy and governance may point to Hyperledger Fabric. Use Docker and local chains like Ganache to containerize, test, and easily reproduce your experiments. For almost every blueprint in this course, your data lake will mix three streams. First, start fast with public datasets from Kaggle, FAO, Mimic, and similar sources. They let you prototype and benchmark. Second, add synthetic data from GANs or simulators to explore edge cases and boost privacy. Third, negotiate carefully governed access to Saudi municipal, farm, or hospital data to make the research locally impactful. When you design an AI blockchain system, you must prove that both the brain and the plumbing work well. For the AI models, emphasize predictive quality, accuracy, and F1 for balanced performance, and ROCAUC to understand behavior across thresholds. For the blockchain layer, emphasize engineering quality, throughput in transactions per second, and the economic cost per transaction, such as gas usage. To validate a PhD blueprint, you usually move from simulation to progressively more realistic deployments. Begin by modeling your system and running ablation studies. Compare architectures with and without blockchain or advanced AI components. Then stress test the design, increase transaction or request rates until the system breaks. Finally, benchmark everything against strong baselines, such as existing centralized platforms used by Saudi institutions. This is the core mental model for every project you design in this course. First, define the problem and research protocol so they're precise, measurable, and grounded in the Saudi context. Then design your architecture layers from data through AI and blockchain components. Next, build the stack and datasets needed to test your ideas. Finally, validate with clear metrics and experiments. You loop through these steps until your thesis is defensible and solid.